All right. So now let's talk about integrals. You may say, haven't we been doing integrals? No. So far, we've actually just been computing antiderivatives. We have not been doing anything with integrals, right? Remember, integrals are areas under a graph, right? They have limits of integration. Okay, so substitution rule for integrals is very much like substitution rule just for antiderivatives, right? The only thing is we need to change three components. All right, so what does a typical integral look like? So a typical integral looks like this. The integral from a to b of the function f of x dx. So if I use a u substitution to figure this out, what has to change? All right, so the first thing that has to change is what's called the integrand. So this function without the dx is called the integrand. So that's what we've been doing so far, right? We've been changing the function from x in terms of u. The next thing that has to change is what's called the differential dx. So notice we've also been doing that so far, right? We've been writing the dx in terms of du. So far everything is like normal. But the last thing that we actually need to change, so these two numbers, a and b, those also have to change. Right? Why do those numbers have to change? Those numbers are values of x. They're not values of u, right? Think about what happens when you do a substitution. Right? You might have some function here, f of x. So the area of that region is the integral of f of x from a to b. Now you translate that to u, right? Now, when all is said and done, when you actually translate this function from x to u, you're going to have a different function here, right? Think about just the previous example. I started with this function, 9x squared minus 6, blah, 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 and then I ended up with 3 over u. I mean, those are different functions, right? So the function g of u might actually end up maybe looking like this, right? Who knows? It depends on what your substitution is exactly, right? So when you change the area, when you do substitution rule, what you're really doing is you're somehow transforming one area into another area. And there's no reason to expect that the left and right vertical lines here are the same, right? X equals A and X equals B. There's no reason to expect that. So in general, you would get two different numbers here. Okay. Now let's look at an example of how this works.